Chapter 1, Physical Quantities, Units and Measurements, Part 1. We will be covering an overview of what you will be covering in physics for these 2 years, and 1.2, which is what are physical quantities. Okay, so this is a broad overview of the study of physics in your 2 years in Hawaii. Okay, in the first year, in Sec 3, you'll be covering general physics, thermal physics, and wave and sound. Okay, and in Sec 4, we'll be covering light, electricity, magnetism, and radioactivity. Okay, so we move on to the main section, which is what are physical quantities. These are the learning outcomes. Okay, physical quantities are anything that can be measured. It usually consists of a number and a units. Okay, and in physics, we are very particular about units because there are a lot of formulas, and every time you sub into a formulas, okay, the quantities that you are subbing into the formulas must be in SI units. Why SI units? Because SI units is the standardized units that is recognized worldwide. So for example, you see over here, this can be found at the overhead bridge. It means that this overhead bridge is 4.5 meters in height. So this is a height, it's a physical quantity because I can measure it. It has a number, numerical magnitude 4.5, and it has a unit. This unit meter is the SI units, okay, for length. Okay, and it's recognized worldwide. So whenever we do things, okay, we usually label it in terms of their SI units. We don't label it in terms of 4.5 inch, 4.5 yards, 4.5 foot, etc. Okay, when we represent numbers, quantities, it is recognized worldwide that meters is the SI unit for length. Okay, so come back to here. What is a physical quantity? As what I mentioned, it is anything that you can measure and it has a magnitude and a unit. So I'm going to give you 2 examples. Okay, so the first example, 5 kg is a mass, it is a physical quantity. So you can measure it using a electronic mass balance, and it gives you a number, numerical magnitude 5, and it gives you a unit, which is kg. And then 10 cm is a length. You can measure it using a ruler. It gives you a numerical magnitude, which is 10, and a unit, which is cm. Other examples of physical quantities that you can measure are like time. I can measure 10 seconds. I can measure 10 hours. Okay, I can also measure temperature like 5 degrees Celsius, 10 degrees Celsius, etc. Okay, what are some things that are not physical quantities are like colors. Oh, the color is blue. Okay, the color is light green. Okay, these are not physical quantities because they have no numbers and they have no units attached to them. Okay, so there are 6 very basic quantities that you must memorize. This table can be found in your textbooks. Okay, so the 6 very basic quantities are as follows: length, mass, time, electric current, temperature, and amount of substance. Okay, and you must know what is the SI unit for these 6 basic quantities, or we call it the base quantities. So how do I remember this table? I remember it, I rearrange it, and I remember it by using the following. The last man at the castle. So okay, I will have time or temperature, and I need to know the SI unit is seconds. Last is for length in meters. Man is for mass in kg. At is for amount of substance, mole. The is again for either time or temperature. And just take note for temperature, although we often use degrees Celsius, but the SI unit for temperature is actually Kelvin. Okay, later on I'll show you the conversion between Kelvin and degrees Celsius. And then for current, okay, it's represented by castle. So the last man at the castle. That's how I remember my 6 base quantity. The last man at the castle. Okay, and then current is for ampere. Okay, so this This one in blue box is not compulsory, but just for your general knowledge. Okay, 0 Kelvin corresponds to minus 273 degrees Celsius. So if you are at 0 degrees, you are actually at 273 Kelvin. Okay, okay, then next. Okay, but not all quantities are represented by these 6 base quantities. There are definitely more things that we can measure other than this length, mass, time. Okay, for example, we can measure speed, we can measure volume, we can measure area, we can measure density. Okay, so density also have a number and a unit. Okay, speed also have a number and a unit. They are all quantities. Okay, but we don't call them the base quantities because they are formed from multiplication or division of base quantities. So for example, speed. Okay, speed is actually distance per unit time. Okay, or distance over time. So the base quantities for speed is actually length, which represents distance, and time. Okay, so we could say that speed is derived from the base quantity of length and time, and because speed is a derived quantities. So for derived quantities, the SI units are derived from their base quantities. So its distance is meters and time is seconds. So it's meters per second. Okay, just take note for physics. We can write units in terms of meters per second like this, or very often you can find it in textbook. We usually write meters per second in terms of like this. We can in textbook sometimes you might see like this. Okay, ms minus 1. The minus 1, it just means divide. Okay, so if I have something which later on you will learn acceleration is meters per second square. Okay, I can also write it as ms minus 2. Okay, so for example, like density is kg per meter cube. I can also write it as kg m minus 2. Okay, the minus is actually means divide. Okay, so these are common units that you see in a lot of physics question rather than this. Okay, so just for your intro. And then next you can scan this to do a crossword puzzle about physical quantities and their units. Okay, then next we move on. In physics, sometimes when we measure things, the numbers that doesn't come out very nice. It can be very big or very small. So we often use prefix to represent things that are very big or very small. Okay, so this is a list of prefix that can be found in your textbook, and you need to know them. Okay, for very, very big numbers, they are represented by prefix from kilo onwards. So kilo, okay, is small letter K, and then the factor is 10 to the power 3, mega is big M, and then the factor is times 10 to the power 6, giga, big G, okay, and the factor is times 10 to the power 9, and tera, big T, is represented by 10 to the power 12. Okay, and then for smaller numbers is represented by the following prefix. Okay, we have deci, which is small, things that are smaller. Okay, things that are smaller, we usually represent it by small letters. And things that are bigger, we represent it by big letters, except for kilo. Kilo is still in small k. Okay, so for deci is small d. Okay, it's 10 to the power minus 1. Centi is 10 to the power minus 2. Milli is 10 to the power minus 3. Micro looks like a U with a longer tail at the front. Okay, so this is micro. It represents 10 times 10 to the power minus 6. And then nano means times 10 to the power minus 9. Okay, so all this represents smaller numbers. Okay, and then another way in which we could represent very big or very small numbers is to use standard form. You will also learn about standard form in your maths later on. So how to represent numbers in standard form? We represent it in this yellow box like this. It represents A times 10 to the power n, whereby A must be between 1 to 10. It can be decimal place number. Need not be a whole number as long as it's between 1 and 10. And while times 10 to the power n must be an integer. Okay, means it must be a whole number. So for example, I have 16,800. If I want to represent it in terms of standard form, I need to be a times 10 to the power n. A must be between 1 to 10, so it must be 1.68. Okay, so this is my a, and times. So I shift my decimal place back by 1. Just draw, I shift my decimal place by 1, 2, 3, 4. So times 10 to the power 4. Okay, and then next, if I have 0.01 nanometers, okay, so if you were to use your prefix, 0.01 nanometer means nano means times 10 to the power minus 9 meters. Okay, so if I want to change it to standard form, 0.01 is not between 1 and 10. So I will change it to become 1. So I shift my decimal place 1, 2. So this times 10 to the power minus 2. Then times 10 to the power minus 9. So this section is equivalent to this section. 0.01 is actually 1 times 10 to the power minus 2. So I must continue my times 10 to the power minus 9. So I will have 1 times 10 to the power minus 11. Okay, next. Okay, these are more examples of how I can use prefix and standard form. So you can see the first one, 5,000 grams. Okay, I can change it to 5 times 10 to the power 3 grams, and 10 to the power 3 means kilo. So if I don't want to write times 10 to the power 3, I can put kilograms over here, and then 0.001 seconds is actually 1 times 10 to the power minus 3 seconds. Okay, and then the minus 3 is actually corresponding to the prefix of milli. So I can change it to 1 milliseconds. This milli, this kilo, and this milli actually represents 10 to the power 3 and 10 to the power minus 3. Okay, so you can pause the video here and try the following. Okay, let's go through the following. So the first one, I have 6 zeros behind the 3. Okay, so it's 3 times 10 to the power 6. Okay, so 10 to the power 6, you go back to your prefix, it means mega. Okay, next one, I have 19. I want to change it to 19, and you can see that there is actually 7 zeros before 19. So it's 19 times 10 to the power of minus 9. Okay, so if I go back to my prefix, minus 9 stands for nano. So it's actually 19 nanoseconds. Okay, and then next one, 15 microjoules. Okay, so micro, you go back to your prefix, micro means times 10 to the power minus 6, so 15 times 10 to the power minus 6. So if I were to work it out, okay, I will become this. Okay, next one, giga. Okay, giga actually represents 10 to the power 9. So if I were to work it out, it's 6 and 9 zeros behind it. Okay, those are very straightforward, whereby you only have one type of units, like meters, seconds. But sometimes questions will ask you to convert things like this: 30 kilometers per hour. This representation is actually same as kilometers per hour. It's a speed. Okay, so instead of per hour, slash hour, I just put it as hour minus 1 in SI units. So you know that the units for speed is not kilometers per hour, it's meters per second. Okay, so SI units meters per second. So I need to change this to meters per second. So some of the useful things that you need to take note is 1 kilometer is 1,000 meters, and then 1 hour is actually 60 times 60 seconds, which is 3,600 seconds. So the first step, I'm going to convert this into a fraction form. So I put 30 kilometers per hour. So 30 kilometers divided by 1 hour. Okay, so the next step, okay, I want to change this to meters per second. So I'm going to get rid of kilometers. I'm going to get rid of hours. Okay, so I put a times something else, which must be equivalent to 1. Something times 1 times 1, you will still get back the original value, which is 30 kilometers per hour. So how do I make it to be 1? So you can take a look. I do 1 hours. Okay, let's say I want to get rid of my hours first. Okay, it doesn't matter if you want to get rid of kilometer or hours first, doesn't matter. So I want to get rid of hours first. So if I want to get rid of hours first, I put hours at the top, so I can cancel it away. And I put seconds at the bottom. Why seconds? Because I want to convert it to seconds. I don't want hours anymore. I want meters per seconds. So 1 hour is equivalent to 3,600 seconds. Okay, so this value is actually 1. This fraction is actually 1. Okay, so I put like this, I can cancel away my hours. So next one, I need to cancel away my kilometers. I don't want my kilometers anymore. I want it to be meters. So I will to put my kilometers at the bottom. Okay, kilometer at the bottom and meters at the top. So kilometer at the bottom so that I can cancel away my kilometer. So 1 kilometer is 1,000 meters. Again, this fraction must be equals to 1 because I don't want to alter the value. Anything times 1 will be back to the same value. So these two fractions must be equivalent to 1. I'm just playing around with the units. 1 hour is 3,607 seconds. 1 kilometer is 1,000 meters. Okay, so if you can see that I have already eliminated my kilometers, I have already eliminated my hours, I'm left with meters and seconds. So I'm equivalent to 30,000 divided by 3,600 seconds, and I will get my answer 8.3, and I'm left with meters per second. Okay, next one, we go into a little bit more challenging one. This one, again, I have 2 different units, kg, the cube. I want to change it into gram, cm cube. But this is even more challenging because this one has cube. Okay, every time when you see units with cube and square, please pay particular attention to it. Okay, so what does it mean? Okay, so I do a sidetrack working over here. Okay, I have meter cube and cm cube. Okay, people like to do 1 meter is 100 cm. So 1 meter cube is 100 cm cube. This is wrong. Okay, when I cube my units, I need to cube my entire equation. So can you see 1 meter is 100 cm. So if I want to have a cube, I need to 1 cube meter cube equals to 100 cube cm cube. Okay, so 1 cube is 1 times 1 times 1. So it's still 1. So 1 meter cube is actually 100 times 100 times 100. So it's actually 1 million cm cube. Okay, the same goes for cm. So 1 meter is 100 cm. Okay, you always go without the square or the cube. Okay, so if I want square, is 1 square meter square equals to 100 square cm square. So 1 meter square is actually 10,000 cm square. Okay, the same for square or cube. Okay, so let's go into it. So the first step, I'm going to put it into a fraction form, 270 kg. Then I put my meter cube at the bottom. Label it in fraction form, be easier for you. So I need to get rid of kg, I need to get rid of meter cube. Okay, so let's say I want to get rid of kg first. So I must times, I put kg at the bottom, grams at the top, because I want to change it into grams. So again, this fraction must be equivalent to 1. Okay, so 1 kg is 1,000 grams. So over here, I can cancel away my kg. Next, I need to get rid of my meter cube. So I put my meter cube at the top and my cm cube at the bottom because I want to change it into cm cube. And then based on your side working, you should know that 1 meter cube is 1 million cm cube. So again, this fraction is equivalent to 1. And again, I can cancel away my meter cube. So I will be left with 270 times 1,000 grams times 1 over 1 times 1 million cm cube. Okay, and if you work out in your calculator, you should be able to get 0.27, and I will be left with the units grams per cm cube. Or I can write it as grams cm minus 3. Okay, this way of presentation is fine as well. Okay, these are some QR codes that you can scan to try on questions yourself. And that's it.